Okay. Today, we are going to talk about special right triangles. We are going to talk about one of two of them. Most of the time they're taught together. We're going to separate them because the biggest thing that happens is people get them confused. But you need to memorize the order of a special right triangle. If you can memorize the pattern, everything other than the memorization is all algebraic. So this can be super easy if you memorize it, and it can be impossible if you don't memorize it. So take the time to draw the picture that you see and write the words down. I'll give you a few seconds to copy it.
Few seconds? Minutes?
Okay. In a 30, 60, 90 degree triangle, it says the hypotenuse is 2 times the length of the short leg. If I let the short leg be a variable, I'm going to say that it's A. It says the hypotenuse is 2 times as big. What does that mean the hypotenuse is going to be? 2A. It says the long leg is the square root of 3 times the length of the short leg. So if the short leg is A, the long leg is what? Okay, so I'm going to write down the short leg times the square root of 3. So I'm going to write A square roots of 3 because it's implied that it's multiplication. Okay? You need to memorize this triangle, because everything that we do with a special right triangle, 30, 60, 90, is going to be based off of this. Okay? So you need to memorize what this actually looks like. If you memorize this, the equation will write itself into the triangle, and all that'll be left to do is solve it algebraically. The hardest side to work with is the long leg. The other 2 sides are easier, and you'll see why in a minute. So the hypotenuse is 2A. The short leg, which is across from the 30, is A. It's kind of your starting point. And the long leg across from the 60 is A square roots of 3. Everybody good? Can I go to the next slide? Every slide from this point on are examples. So I'll give you just a little bit to copy that triangle down, and then we'll talk about how to set it up. Okay. If you memorize the 30, 60, 90 degree triangle, across from the 30 is A. Across from the 60, A square roots of 3. Across from the 90, 2A. So we're going to put that kind of notation in here. Across from the 30 is A. So I'm going to put equals A. Across from the 60 is A square roots of 3. And across from the 90 is 2A. Well, if A is equal to 3, what can I put in place of this A that's here? 3. X equals 3 square roots of 3. And if I come up here and I replace this one with 3, this would be y is equal to 6. Now that's the easiest side to work with when they give you the side that's across from a 30-degree angle. And we're going to do one from each side. Again, This is about being able to memorize that triangle. If you've memorized the triangle, then you know what's going to go across from the 30 is going to be a. What's going to go across from the 60 is going to be a square roots of 3. And what goes across from the 90 is going to be 2a. So across from the 30, I'm going to put a. So x right now is equal to a. Across from the 60 is going to be a square roots of 3. So y is a square roots of 3. Across from the 90 is going to be 2a. And you can see that it's written in algebraic equation for us. I know that 2a is equal to 8. Algebraically, what would I do to solve for a? Divide by 2. So a is equal to 4. Once I know what a is equal to, I can go back and I can plug it back in. So how big is x? X is 4. And how big is y? 4 square roots of 3. It's all about memorizing this so that you can write those in your triangle.
See, it's easy, but like the moment you're going to have to simplify that 4 to the square roots of 3.
You're not going to have to simplify that. It is simplified. 4 square roots of 3 is done. The two easiest problems that we're going to work with, we've already done. The third example is going to be the hardest one. And it's easy once you get used to seeing what happens. Doesn't have to be hard. We just need to make sure that we've memorized this special right triangle. What do we put across from the 30? A. So x is a. What do we put across from the 60? A what? A square roots of 3. Notice it wrote an algebraic equation. Across from the 90 is 2a. So what we have for our equation is this. A square roots of 3 is equal to 6. What would I do to get this a by itself? Divide by the square root of 3. This is why this particular problem is harder. Is because we have a rule in math that says I can't leave a square root in the denominator. Okay? Just can't leave it there. It's not proper. What is the only number that I can multiply any number by without changing its value? 1. So I want to find a 1 that I can multiply this by that'll change its appearance but won't change its value. Because the square root of 3 is in the denominator, I want to multiply by the square root of 3 divided by the square root of 3. This has a value of 1, so I'm not changing the value, I'm changing an appearance. That's all that's happening. What's going to be in the numerator? 6 square roots of 3. If I multiplied the square root of 3 times the square root of 3, what would it give me? It would give me 3. This can be simplified because 3 goes into 6 how many times? So, a in this case is 2 square roots of 3. How big is x? 2 square roots of 3. We just plug that back in. If I plug it in here, I'm taking 2 times 2 square roots of 3. How big is y? Say it, Brichelle. 4 square roots of 3. We simply multiply the 2 times the 2. This one is only harder because I had the square root in the denominator. And if it's in the denominator, I'm going to multiply by whatever that square root is. I'm going to multiply by it divided by itself. It gets it out of the denominator.
We'll do another one.
Okay, if I give you this as x, and this is y, and this is 15. What am I going to put across from the 30? X equals a. What's going to go across from the 60? A square roots of 3. There's my algebraic equation that I end up having to solve. And across from the 90 is 2a. So I have a square roots of 3 is equal to 15. How would I get a by itself? Divide by the square root of 3. What can't I leave in the denominator? I can't leave this square root. So I'm going to multiply by, technically I'm multiplying by 1. I want to change the value, I just want to change its appearance. In the numerator, I still have 15 square roots of 3. But in the denominator, I have now what? 3. And this will simplify because 3 will go into 15 how many times? 5. If this 3 does not go into 15, leave it that way. If this would have been 17, it would have said 17 square roots of 3 over 3. Nothing wrong with that. Well, in this case, x then would have been 5 square roots of 3. And y is going to be 2 times 5 square roots of 3, which is 10 square roots of 3. Good?
Wait, so if like the number was say 16, you had to.
I would say 16 square roots of 3 over 3 because it wouldn't simplify. And when I multiplied it by 2, I would take the 16 times 2. So it would be 32 square roots of 3, still over what? Still over 3. Okay? If it won't simplify, it just won't simplify, and it's going to still be in that fraction form. That's all. Okay? Here are 2 more examples. We've already done a couple like this, but we'll do a couple more. I'll give you a second to... Again, to me, this is all about memorizing that triangle. Across from the 30, we put A. Across from the 60, we put A square roots of 3. And across from the 90, we put 2A. This is one of the easiest ones because the equation is already solved. A is equal to what? 7. So when I come over to find y, what am I going to replace a with? So y equals 7 square roots of 3. And when I go to find x, x is equal to 2 times 7, which is 14. This one looks harder, doesn't it? Because what's already in the problem? A square root of 3. But in fact, that square root of 3 is going to make our problem easier to work with. What are we going to put across from the 30? A. What goes across from the 60? A square roots of 3. There's my equation. And across from the 90 is 2A. So I have A square roots of 3 is equal to 10 square roots of 3. What would I do to get A by itself? When I divide by the square root of 3, what happens this time on both sides of the equation? The square roots cancel out. A is equal to 10. So I can come back over here. X is going to be 10. And Y is going to be 20. 2 times 10.
The long side equals
The long leg is 10 square roots of 3. That's what they gave me, right? The short leg was 10. And the long leg, the hypotenuse is 20. The hypotenuse is twice as big as the short leg, 10 times 2. And the long leg is the square root of 3 times as big as the short leg, 10 times the square root of 3. Everybody good? And I'll give you a second to write this problem out. When I'm given a word problem like this, the perimeter of an equilateral triangle is 54. Find the altitude of the triangle. There's a couple things that I do. First off, I want to know what are they asking me to find, and they're asking me to find what? The altitude. If they're talking about an equilateral triangle, what do you think I'm going to do? I'm going to draw an equilateral triangle. If the triangle is equilateral, we know all the sides are the same. And how big is each one of the angles then? 60 degrees. Now remember, when we were talking about this last chapter, and I said that these words weren't going to go away, we need to know what an altitude is. What is an altitude? It connects the vertex to the opposite side so that it forms a 90-degree angle or a right angle. Okay? So if that's the case, in this triangle over here, if this is 90 and this is 60, what happened to this 60 up here? It split it into 30 and 30. And the only other information they gave me about this is that the perimeter was 54. If the perimeter of an equilateral triangle is 54, how can I find out the measurement of each side? Divided by 3. 54 divided by 3, 18. So I'm going to put that 18 in this triangle. And what we're going to look at is we're going to look at one piece of the triangle. Because the part that they're asking me to find is here. So here's my triangle. This is 18. This is 90. This is 60. This is 30. This is the part that I'm looking for. What goes across from the 30?
A square root.
What goes across from the 30? A. What goes across from the 60? A square roots of, and what goes across from the 90? 2A. And there's my algebraic equation. 2A is equal to 18. So when I divide by 2, A is equal to 9. So this would be 9. In fact, not only did it split this angle in half, it actually bisected this segment that was on the bottom. And I'm going to replace this with the 9 as well. So this is 9 square roots of 3. So my altitude is 9 square roots of 3.